Okay, so a lot of questions have come up about the difference between null and alternative hypotheses. So I thought I might make a quick video to help explain them and the differences a little bit more clearly than the slides. Admittedly, the slides give you very little help. I know some of you have used your textbook and online to supplement, which is great, but I thought I'd make this video just to help out with some of you. So there's two main different types of hypotheses, and we'll talk about them. So the first one is called null hypothesis, and this one we mark with an H subscript 0. This basically means, in words, that there is no difference or change between the two groups or means. And if you think about what that means, there's no difference, then you could also say it that they will be the same. And we know we use the equal sign to mean the same. So we're talking about one group having a mean that equals another group, and that's the null hypothesis. Now, the other type of hypothesis is called alternative or research hypothesis, and there are two types of that. So there's one called a non-directional hypothesis, and if you look, the alternative hypothesis is marked by a little a. Also, sometimes people use numbers as the subset, because sometimes you'll have multiple hypotheses, in which case you'd have H1, H2, H3 for all your alternatives, but the null would still be H0. Anyway, so the non-directional alternative hypothesis is simply saying there is a difference between these two things, but we're not exactly sure which direction that difference is going to be. We don't know if one mean is going to be more or less than the other mean. So we're just saying there's a difference. This again is called non-directional, and it's a two-tailed test. Now if we look at down here, there is a difference between these two things, and we think that one group is going to be more or less than the other group. In that case, then we use what's called a directional hypothesis, and we use the greater than or less than signs. And this would be done with a one-tailed test. So if you think about these different hypotheses, the null hypothesis is often what researchers or scientists do not want to be true, right? So let's say we do an intervention, and we're in a math class, and we separate them out into two groups, and one group we keep teaching the same way, and the second group we teach them a really cool new way we just made up. Well, if we did all that work, and then at the end the mean score of these two groups was the same, the null hypothesis would be true, and we would be a little bit upset as scientists because, wow, we wasted a bunch of time teaching this new cool way. Now, why we write the alternative or the research hypothesis, because this is what we hope will happen, or what we expect to happen, or what we predict to happen, or what we hypothesize to happen. So this is saying, let's say we weren't sure if this new cool way of math was going to make scores better or worse, but we did have a good idea that they would be different from the kids who were just teaching regular. In that case, we would use this non-difference here. And finally, what we probably in this case are hoping is that the new cool way is going to result in scores, the mean score, higher than the other folks. In that case, we would use a greater than or less than, depending on which place we wrote our groups. So let's go ahead and put some of those symbols in there. So we always typically write the null hypothesis using mu, and that's because this is the Greek symbol for, again, for population statistics. So this is the null hypothesis. So basically the idea that all of the population in this group 1, this mu 1, so this group that we didn't do anything with, is equal to the mu, or the population mean, of the second group that we did this new cool math thing with. Now when you look down here for our research and alternative hypothesis, I've used Roman letters because I'm imagining that I only have a sample of all the possible people I could be looking at. So it depends for you. If you for some reason do have a population to test your hypothesis on, then you can actually use mu's here too. But in this case, I'm showing you what it would look like in a sample. So again, this is x bar 1, so the mean of the first group is not equal to, is different than the mean of the second group. And then if you have a directional alternative or research hypothesis, then you would say the mean of the first group is greater than the mean of the second group, or the mean of the first group is less than the mean of the second group. And that covers null and alternative hypotheses. Let me know if you have extra questions.